October 12, 1943. The morning sun cast harsh shadows across the volcanic soil outside Naples, Italy. Tenente Giulio Moretti of the Centauro Armored Division lowered his field glasses and studied the abandoned American vehicle sitting motionless beside the bombed-out farmhouse ahead. Smoke still drifted lazily from a burning German half-track 200 meters beyond it, the result of the chaotic Allied advance that had swept through this sector just hours earlier. Moretti ordered his reconnaissance patrol forward cautiously. The Americans and British had proven themselves capable of elaborate traps during the grinding campaign up the Italian peninsula. His men approached the vehicle with rifles ready, watching for tripwires or concealed demolition charges. What they found instead was an intact M10 tank destroyer, its crew having apparently abandoned it during a mechanical issue or tactical withdrawal. The vehicle bore the markings of the 701st Tank Destroyer Battalion. Its registration number, USA 4087329, was stenciled clearly on the hull. As Moretti climbed onto the sloped rear deck and peered into the open-topped turret, he experienced something unexpected. This American machine, with its peculiar configuration and unconventional design, represented an approach to armored warfare that Italy had never seriously considered and would never have the industrial capacity to replicate. What Tenente Moretti didn't know as he examined that M10's interior was that this single captured vehicle would trigger one of the most profound reassessments in Italian military engineering. The tank destroyer before him embodied not overwhelming firepower or impenetrable armor, but something far more significant to a nation whose armored forces had struggled throughout the war with chronic mechanical failures and tactical inflexibility. It represented mobility as a weapon system, an American industrial philosophy that prioritized operational tempo over static defensive capability. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This M10 would soon travel from the battlefields of southern Italy to testing facilities near Rome, where Italian engineers and German advisors would conduct comprehensive evaluations. What they discovered would force uncomfortable admissions about the fundamental weaknesses in Axis tank design philosophy and the insurmountable advantages that American industrial methodology provided. The early afternoon air was thick with dust, and the acrid smell of burned fuel as Moretti's men conducted their initial inspection. The M10 Wolverine, as American crews called it, was unlike anything in the Italian armored inventory. At first glance, it appeared to be a modified Sherman tank, sharing the same lower hull and suspension system, but the similarities ended there. The turret was entirely different, a pentagonal structure with sloped armor and an open top. The main armament was immediately impressive, a 3-inch gun with a barrel extending well forward of the turret face. This was substantially more powerful than the 47mm guns that armed Italy's most modern tanks, the P-40 heavy tank, which existed in such limited numbers that most Italian tankers had never even seen one. Sergente Maggiore Paolo Rinaldi was the first to climb into the commander's position. At 31 years old, Rinaldi had served in Italian armoured units since 1938, experiencing the disasters of North Africa firsthand. He had commanded Fiat M1340 light tanks in Libya, vehicles that were dangerously obsolete even when new, with riveted armour that spalled lethally when struck and gasoline engines that turned the tanks into funeral pyres. As Rinaldi settled into the M10's commander's cupola, his first impression was of space and visibility. The open-topped turret provided unrestricted overhead observation. The commander's position offered excellent sight lines in all directions. Compared to the cramped, blind interiors of Italian tanks where commanders struggled to see anything beyond their immediate front, this American vehicle felt almost luxurious. Rinaldi called down to Moretti with words that would appear in subsequent reports. "Tenente, this machine is designed for the crew to actually fight effectively, not merely to survive inside a moving pillbox." It was an observation that cut to the heart of Italian tank design failures. Italian tanks had been designed primarily as mobile bunkers, with crew efficiency and tactical flexibility as secondary considerations. Moretti climbed up beside Rinaldi and conducted his own examination. The interior layout impressed him immediately despite the vehicle's relatively Spartan appointments. The driver's position in the front left hull featured surprisingly good visibility through a combination of direct vision blocks and periscopes. The assistant driver/machine gunner position on the front right provided similar visibility. The gun crew in the turret, commander, gunner, and loader, had ample working space. The 3-inch gun, officially designated the M7, was mounted with a traverse mechanism that appeared smooth and responsive. Ammunition racks were clearly organized and accessible. The entire fighting compartment was arranged with an obvious logic that prioritized rapid engagement and sustained fire. The capture of this particular M10 came during the chaotic Allied landings at Salerno in early September 1943, followed by the rapid advance toward Naples. The 701st Tank Destroyer Battalion had been among the first American armored units ashore, supporting infantry divisions as they fought through determined German resistance. This specific M10 had apparently suffered a mechanical failure, possibly transmission-related, during operations near Avellino. Rather than attempt field repairs under fire, the crew had disabled the weapons and withdrawn. For the Italians, now fighting alongside their former German allies under the newly declared Italian Social Republic in the north, or in some cases simply trying to survive the chaos of their nation's military collapse, this abandoned vehicle represented an intelligence windfall. Rather than attempting to press the M10 into immediate service, which would have been nearly impossible given ammunition incompatibility and maintenance requirements, orders came from the Comando Supremo remnants working with German advisors to transport this vehicle to testing facilities. Someone in the fragmenting Italian military command structure understood that studying American armored vehicle design might provide insights more valuable than one additional tank destroyer. The M10 belonged to Company A, 701st Tank Destroyer Battalion, part of the 82nd Airborne Division's armored support during the Salerno landings. Its serial number identified it as one of 4,993 M10 tank destroyers, built by Fisher Body Division of General Motors, between September 1942 and December 1943. The vehicle was approximately 1 year old, with roughly 300 operating hours on its twin General Motors 671 diesel engines, relatively low mileage for comprehensive technical evaluation. The journey from battlefield to testing ground began immediately, once coordination was established between Italian and German technical services. The vehicle was to be transported to the Centro Studi Motorizzazione, the Italian Army's vehicle testing center located south of Rome near Nettuno. The orders were explicit: examine this vehicle thoroughly to understand American tank destroyer doctrine and engineering principles. The crew assigned to recover and transport the M10 faced an immediate practical challenge. None of them had ever operated an American armored vehicle. The controls, instrumentation, and general layout were completely unfamiliar. Sergente Rinaldi, given his experience and demonstrated mechanical aptitude, was assigned to lead the recovery team. What followed provided the first dramatic lesson about American vehicle design philosophy. With only a brief examination of the controls and some educated guessing about operational procedures, Rinaldi managed to start the twin diesel engines. They rumbled to life with a deep, authoritative sound completely different from the high-pitched scream of Italian gasoline engines. The transmission, though unfamiliar, proved relatively intuitive to operate. Within 2 hours of beginning their examination, Rinaldi's team had the M10 running and mobile. They drove it 28 kilometers to a secure assembly area without a single mechanical issue. This was a revelation. Italian tanks, particularly the M1340 and M1441 models that formed the bulk of Italian armored forces, required extensive crew training just to operate reliably. Transmissions were fragile and temperamental. Engines overheated regularly. Mechanical failures during road marches were expected rather than exceptional. Tenente Carlo Barbieri, a mechanical engineer who had been assigned to evaluate captured Allied equipment, accompanied the M10 during its initial recovery. His preliminary report, dated October 15, 1943, noted that the American tank destroyer demonstrated an engineering approach fundamentally opposite to Italian practice. Where Italian vehicles were mechanically complex and required skilled operators, this American vehicle appeared designed to be operated by soldiers with minimal technical training. The controls are straightforward, almost crude in their simplicity, yet the vehicle functions effectively. From the temporary assembly area, the M10 was loaded onto a railway flat car for transport north. German logistics officers facilitated the movement, recognizing that intelligence gained from studying American equipment benefited all Axis forces. The vehicle arrived at the Centro Studi Motorizzazione in late October 1943 and was immediately assigned for comprehensive evaluation. The testing facility near Nettuno had served as Italy's primary vehicle testing centre since the 1920s. By 1943, it had become a depressing reminder of Italian industrial inadequacy. The facility's equipment was largely obsolete, its technical staff depleted by casualties, and the chaos of Italy's collapse as a unified combatant nation. Nevertheless, the engineers who remained were competent professionals who approached the M10 with systematic thoroughness. Italian engineers, supplemented by German technical advisors from Warproof, the Wehrmacht Weapons Testing Office, began their methodical examination in early November. Teams measured every aspect of the vehicle: armor thickness at every point, angles of every plate, dimensions of every component. They stenciled measurements directly onto the hull in white paint, just as German engineers had done with captured Shermans at Kummersdorf. The measurements revealed a vehicle with modest armor protection. The turret front was 57 mm thick at an angle of approximately 45 degrees. Hull front armor was 38 mm at various angles. Side and rear armor was even thinner, in many places only 19 mm. This provided adequate protection against small arms and shell fragments, but virtually any dedicated anti-tank weapon could penetrate the M10 at combat ranges. The 3-inch M7 gun was substantially more powerful than anything in Italian service. Italian engineers calculated that it could penetrate approximately 100 mm of armor at 1,000 meters, enough to defeat the frontal armor of most German tanks and certainly any Italian armored vehicle. The gun's mounting allowed for traverse and elevation mechanisms that appeared robust and well-engineered. One feature particularly impressed the Italian observers. The gun mount incorporated a counterweight system that balanced the long barrel, making manual traverse relatively easy even without power assistance. This was a significant engineering refinement. Italian tank guns, particularly the longer 47 mm weapons on P-40 tanks, were notoriously difficult to traverse manually, requiring substantial physical effort from the gunner. Then the engineers started the engines. The twin General Motors 671 diesel engines were a revelation. Each engine was a two-cycle diesel, supercharged, developing approximately 110 horsepower. Combined, they provided 220 horsepower to drive a vehicle weighing approximately 29.5 tons. This power-to-weight ratio was substantially better than any Italian tank. The engines started easily, idling with a characteristic diesel rattle that was far quieter than Italian gasoline engines. Oil pressure stabilized quickly. There were no obvious leaks, no unusual vibrations, no signs of the chronic problems that plagued Italian power plants. The cooling system maintained stable temperatures, even during extended idling. Ingegnere Antonio Castellano, a civilian engineer from Fiat who had worked on Italian tank development, recorded his initial impressions in a report dated November 8, 1943. The American power plant demonstrates engineering priorities we have consistently failed to implement. Where we pursue adequate power output from limited displacement using high-revving gasoline engines, the Americans use larger, slower-running diesel engines that prioritize reliability and fuel efficiency. The twin-engine configuration provides redundancy we never considered. If one engine fails, the vehicle remains mobile, though at reduced capability. This is intelligent design for combat conditions. The testing program at Nettuno was comprehensive despite the facility's limitations. Italian engineers, working alongside their German counterparts, put the M10 through every evaluation their resources permitted. They drove it across obstacle courses. They measured its speed, acceleration, turning radius, and cross-country mobility. They test-fired the main gun, using carefully hoarded stocks of captured American ammunition. The automotive testing provided stark revelations. The M10's mobility was extraordinary by Italian standards. On improved roads, the vehicle could achieve speeds approaching 48 km per hour. Cross-country performance was equally impressive. The familiar Sherman suspension, with its vertical volute spring system, provided acceptable ride quality and kept the vehicle mobile across terrain that would have immobilized Italian tanks. Maggiore Giuseppe Ferretti, who had commanded tank battalions in North Africa and understood Italian armor's tactical limitations intimately, supervised much of the operational testing. Ferretti was a realist who had watched Italian tanks fail repeatedly against British and later American forces. His assessment, written in December 1943, was brutally honest. This American vehicle represents everything our tanks are not. It is mobile where ours are slow. It is reliable where ours constantly break down. It is designed for sustained combat operations, where ours are designed for parade ground demonstrations. Most significantly, it embodies a tactical doctrine we never developed. The Americans understand that mobility is a weapon. They built this vehicle to move rapidly, engage enemy armor from advantageous positions, and relocate before effective counterfire. Our tanks are designed to advance slowly and engage in static duels, where armor thickness determines survival. The American approach is demonstrably superior for modern mobile warfare. The transmission testing revealed fundamental differences in engineering philosophy. Italian tanks used complex manual transmissions with multiple gears, often requiring double clutching and significant skill to operate smoothly. The M1340 used a 4-speed transmission that was notoriously difficult. The M1441 used a 5-speed that was marginally better but still required extensive driver training. The M10 used a synchromesh transmission with 5 forward gears adapted from commercial truck technology. The synchronizers allowed smooth shifting without double clutching. The clutch required reasonable but not excessive foot pressure. A novice could learn competent operation in hours rather than the weeks required for Italian transmissions. More importantly, the American transmission showed no signs of premature wear. Italian tank transmissions were fragile, often failing after just a few hundred kilometers of operation. Clutches burned out. Gears stripped. Final drives cracked under stress. The M10's transmission appeared robust enough to last thousands of kilometers with routine maintenance. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Sergente Maggiore Bruno Costa, an experienced tank mechanic who had maintained Italian armoured vehicles throughout the North African campaign, examined the M10's drivetrain with particular interest. His report detailed engineering that prioritized durability through design rather than precision manufacturing. The American transmission and final drives use larger components with generous load margins. The differential is substantially more robust than comparable Italian designs. The track drive sprockets and idler wheels show evidence of superior metallurgy. Every design choice sacrifices marginal efficiency for absolute dependability under combat stress. Costa noted something else that Italian engineers found remarkable. The M10's final drives appeared designed for field replacement. The entire unit could be unbolted and removed with basic tools and standard lifting equipment. Italian final drives were essentially permanent installations. If they failed, which they frequently did, the entire vehicle often had to be transported to depot-level facilities for repair. The suspension system proved equally instructive. Italian tanks used various suspension designs, none particularly effective. The M1340 used a leaf spring suspension that provided horrible ride quality and frequently broke. The M1441 used a bogie system with coil springs that was better but still prone to failure. The P-40 heavy tank used a torsion bar suspension that was theoretically superior but suffered from manufacturing quality problems. The M10 used the Sherman's proven vertical volute spring suspension. Each bogie unit consisted of a pair of road wheels mounted on a vertical coil spring bolted to the hull. If damaged, individual bogie units could be unbolted and replaced in the field using basic tools. The springs rarely failed. The suspension provided acceptable ride quality and kept the vehicle mobile with minimal maintenance. Tenente Colonnello Marco Venturi, who had overseen Italian tank development efforts before the armistice, examined the M10's suspension with a mixture of admiration and frustration. This American suspension is exactly the practical solution our designers should have developed, but never did. It is straightforward, dependable, and maintainable by ordinary soldiers with common tools. Our approach has consistently been to pursue theoretically optimal designs that require precision manufacturing we cannot achieve and specialized maintenance we cannot provide. The Americans understand that adequate performance with absolute reliability defeats superior performance with chronic unreliability. The track testing provided another uncomfortable comparison. Italian tanks used manganese steel tracks that required precision manufacturing. Production quality was inconsistent. Track life varied wildly, sometimes lasting only a few hundred kilometers before pins wore out or links cracked. The M10 used relatively straightforward steel tracks with replaceable rubber pads, identical to the Sherman's tracks. The rubber provided good traction on paved roads and reduced road wear. When pads wore out, they could be replaced individually without removing the entire track. Italian test teams calculated that M10 tracks would last approximately 4,000 to 5,000 kilometers under mixed conditions. Italian tank tracks rarely exceeded 1,000 kilometers and often failed far sooner. Engine testing revealed the most fundamental difference between American and Italian engineering approaches. The twin General Motors 671 diesel engines were derivatives of proven commercial designs. Each was a two-stroke, supercharged diesel that had been used successfully in trucks and buses. Adapted for armored vehicle use, they provided reliable power with remarkably simple maintenance requirements. Italian tank engines were invariably gasoline-powered, usually based on truck or aircraft engine designs, but modified in ways that often introduced problems. The SPA-8TM40 engine that powered the M1340 was theoretically capable of 105 horsepower, but in practice rarely delivered more than 90 horsepower due to cooling problems and poor carburation. The engine overheated regularly, requiring frequent stops for cooling. Fuel consumption was atrocious. Mechanical reliability was abysmal. Dottore Enzo Mariani, an engine specialist from Ansaldo, who had worked on various Italian armored vehicle power plants, wrote an extensive analysis comparing the M10's diesels to Italian engines. The American approach sacrifices peak power density for operational consistency and fuel efficiency. Their diesel engines run at lower RPM than our gasoline engines, producing less power per unit displacement, but with far greater reliability. The supercharging compensates for the diesel's inherent power limitations while maintaining the diesel's advantages in fuel consumption and fire safety. Most significantly, these engines are designed to operate continuously under load for extended periods. Our engines must be nursed carefully, with frequent rest periods, to avoid overheating and mechanical failure. Mariani noted that the twin-engine configuration, while adding complexity, provided genuine redundancy. If one engine failed completely, the M10 remained mobile using the other engine, though at reduced speed and power. Italian tanks, with their single engines, became immobile paperweights the moment the engine failed, which happened with depressing regularity. The operational testing culminated in a comprehensive demonstration in mid-December 1943. This was conducted for a small group of senior Italian and German officers who remained involved in armored vehicle development, despite Italy's military collapse. The M10 was driven extensively across various terrain, including road driving, cross-country movement, and obstacle negotiation. The vehicle performed consistently, After weeks of testing and demonstration runs, the twin diesels still ran smoothly, still started reliably every morning, still maintained stable operating temperatures. The transmission still shifted cleanly. The suspension still absorbed terrain without damage. The M10 needed nothing except fuel, oil, and routine checks. General Major Friedrich Weber, a German armor specialist who had observed the testing, commented that the American tank destroyer represented a level of operational reliability that German vehicles rarely achieved and Italian vehicles never approached. The design priorities evident in this vehicle, mechanical dependability and ease of maintenance, are precisely what the Axis has failed to emphasize. We have pursued performance at the expense of reliability. The Americans have achieved adequate performance with excellent reliability. In sustained combat, their approach proves superior. More testing continued through January and February of 1944, though with increasing difficulty as Allied advances threatened the testing facility. The M10 was subjected to gunnery trials where its 3-inch gun impressed Italian observers. The weapon's penetration performance exceeded anything in Italian service by a substantial margin. The gun's mounting allowed for smooth traverse and elevation. The sighting system, while not particularly sophisticated, was functional and straightforward to use. Tenente Andrea Rossini, a gunnery instructor who had trained Italian tank crews, evaluated the M10's fire control system. The gun laying and sighting arrangements are pragmatic rather than sophisticated, but they are entirely adequate for the vehicle's intended role. The gun is easy to aim, traverse is smooth, and the trigger mechanism is simple and reliable. Our tanks feature overly complex sighting systems that theoretically provide superior accuracy but frequently malfunction. The American approach, simple equipment that consistently functions, again proves more effective than complex equipment that often fails. The M10's interior arrangement particularly impressed every Italian evaluator who examined it. The fighting compartment, though open-topped, was logically laid out with crew efficiency as the primary consideration. The gunner had a comfortable position with adequate space to operate. The loader had clear access to ammunition stowage and enough room to work effectively. The commander had excellent all-around visibility from his position. Most significantly, the entire turret was designed to facilitate rapid engagement. Ammunition was stored in racks with clear organization. The gun's counterbalance system made manual traverse relatively easy. Escape from the vehicle was straightforward through the open top. Every design detail reflected careful consideration of how crews actually fight in combat. Maggiore Alberto Grimaldi, an experienced tank commander who had fought in North Africa, spent several days familiarizing himself with the M10's operation. His assessment, written in a personal letter that survived the war, provided a telling comparison between Italian and American design philosophy. After commanding M1340s in combat for 2 years, operating this American tank destroyer feels like stepping into a different era of warfare. Everything is designed to make the crew more effective. Vision is excellent from every position. Controls are intuitive and responsive. There is room to move and work efficiently. Our Italian tanks are designed as machines that happen to carry crews. This American vehicle is designed as a complete weapon system where crew effectiveness is recognized as paramount to success. After operating the M10, I finally understand why Italian armored forces were consistently defeated in North Africa. We were fighting with obsolete tools against opponents with modern, crew-centered designs. The technical reports from Nettuno began circulating among what remained of Italian military technical services by early 1944. Behind classified covers, the reports documented systematic American advantages in armored vehicle design. The M10 represented mature industrial engineering applied to military requirements. Italian tanks represented inadequate industrial capacity, struggling to produce military equipment. One particularly stark report stated, "The Americans have achieved in tank destroyer design what Italy demonstrably cannot achieve. They have created a vehicle that can be manufactured efficiently, maintained easily, and operated effectively by average soldiers with reasonable training. Our tanks require exceptional maintenance, demand highly skilled operators, and fail chronically despite receiving both. American armored vehicles are strategically superior because they consistently function as designed. Our vehicles are strategically worthless because they rarely function reliably under combat conditions. The psychological impact on Italian engineers and officers who examined the M10 was profound, though tempered by resignation. Italy's industrial base had never been adequate for modern mechanized warfare. The nation's steel production was a fraction of American output. Machine tool availability was limited. Skilled labor was in short supply. Even if Italian designers fully understood American engineering principles, which the M10 evaluation suggested they now did, Italian industry lacked the capacity to implement those principles. Colonnello Francesco Bianchi, who had served as a liaison between Italian and German armored development programs before the armistice, visited Nettuno in February 1944. His report to the fragmentary Italian military command articulated a bitter truth that many had recognized but few had documented so bluntly. This American tank destroyer is not superior to our vehicles because of secret technologies or revolutionary innovations. It is superior because it emerges from an industrial system capable of producing reliable, maintainable equipment in vast quantities. Italy has never possessed such industrial capacity. Our tanks fail not because our engineers lack knowledge, but because our factories lack capability. We cannot produce the precision components, quality steel, and reliable sub-assemblies that American mass production delivers routinely. The M10 demonstrates not American engineering genius, but American industrial maturity. Italy entered this war as an industrial adolescent, attempting to compete with an industrial giant. The German advisors who participated in the M10 evaluation reached similar conclusions, though from a slightly different perspective. German industry was far more capable than Italian industry, yet even Germany struggled to match American production volumes and operational reliability. If the M10 represented typical American armored vehicle quality, and intelligence suggested it did, then the material balance was even more unfavorable than previously calculated. Oberstleutnant Hans Dietrich, a German technical advisor who had worked extensively with Italian armored forces, wrote in his report that Italian use of captured M10s would be logistically impossible. Ammunition supply would be the immediate problem. The 3-inch gun used ammunition incompatible with any German or Italian weapons. Without reliable ammunition supply, the M10 would be useless regardless of its mechanical advantages. Nevertheless, some captured M10 tank destroyers did see limited service with Italian and German forces in Italy. These vehicles were typically used in static defensive positions, where their mobility advantage was irrelevant, but their powerful guns remained valuable. Units equipped with these captured vehicles consistently reported what the Nettuno engineers had documented. The M10s were reliable, easy to maintain, and mechanically superior to Axis equipment, but ammunition scarcity limited their operational utility. Sottotenente Marco Benedetti commanded a small mixed unit that operated a captured M10 near Cassino in March 1944. In post-war interviews, Benedetti recalled his experience with remarkable clarity. "We received the M10 after our last Italian tank broke down beyond repair. None of us had operated an American vehicle before, but within a few hours, we had learned the controls and could drive it competently. This alone was astonishing. Italian tanks required weeks of training. The M10 was intuitive. We used it primarily as a mobile pillbox, moving it between prepared positions to support defensive operations. It never failed, mechanically in 6 weeks of operation. The engines started reliably every morning. The transmission never gave problems. We only abandoned it when we ran out of ammunition and had to withdraw. If Italy had possessed vehicles of this quality from the beginning, perhaps our military performance would have been less humiliating. The operational differences between American and Italian armored vehicles were quantifiable through captured maintenance records and post-war analysis. American data from extended service trials showed M10 tank destroyers averaged between 2,000 and 3,000 kilometers between major overhauls. The twin General Motors diesels typically lasted approximately 400 operating hours before requiring rebuilds, substantially longer than Italian gasoline engines. Italian data painted a dramatically different picture. The M1340's SPA engine was designed for 150 hours between overhauls, but field reports indicated most engines failed after just 80 to 100 hours. The M1441's improved engine lasted slightly longer, perhaps 120 hours under favorable conditions. Transmission failures were even more frequent. Italian tanks often required major transmission work after only a few hundred kilometers of operation. The maintenance requirements told an equally stark story. An M10's twin engines could be removed and replaced by a trained crew in approximately 8 to 10 hours using standard lifting equipment. Italian tank engines required specialized equipment, skilled technicians, and far more time. An M1340 engine change required a minimum 24 hours with proper facilities, often much longer in field conditions. The M10's modular design approach extended throughout the vehicle. Damaged components could be unbolted and replaced. A damaged bogie unit could be swapped in 2 hours. A failed engine could be replaced in a day. Italian tanks required in-place repairs that took far longer and demanded higher technical skill levels that were rarely available in field maintenance units. American support systems extended these advantages further. Spare parts were ruthlessly standardized and interchangeable between vehicles. Repair manuals were clear with extensive illustrations for mechanics with limited formal training. Maintenance schedules were realistic and achievable under field conditions. The supply chain was systematically organized. Italian support systems were catastrophically inadequate. Spare parts were often unique to specific factories or even specific production batches. Interchangeability was theoretical rather than actual. Repair manuals, when they existed, assumed skilled technicians with comprehensive training. Maintenance schedules were optimistic fantasies that bore no relation to actual field capabilities. The supply chain was chaotic even before Italy's military collapse. The cumulative effect was strategically decisive, though Italy's defeat was inevitable regardless of armored vehicle quality. American armored units maintained high operational readiness even during sustained combat. Vehicles that experienced mechanical problems were quickly repaired and returned to service. Italian armored units saw effective strength erode rapidly as mechanical failures accumulated far faster than repairs could address them. In the Italian campaign, entire Italian tank battalions became immobilized not through combat losses, but through cascading mechanical failures. Tanks that broke down were often simply abandoned because repair capacity didn't exist. American M10s and other armored vehicles kept fighting throughout extended operations, maintaining mobility and combat effectiveness that Italian forces could never match. The engineers at Nettuno understood this dynamic with painful clarity. Their reports repeatedly emphasized that Italian armored vehicle development had prioritized the wrong metrics. A tank with impressive specifications on paper that breaks down before reaching combat is worthless. A dependable vehicle with adequate capabilities that consistently reaches combat and remains operational is invaluable. Italian tanks fell into the first category. American vehicles like the M10 exemplified the second. But Italian leadership, or what remained of it in the fragmenting nation, could not address these fundamental problems. The Italian Social Republic in the north was entirely dependent on German support and had no independent armored vehicle development capacity. The royal government in the south was focused on political survival rather than military reconstruction. Italy's armored forces simply withered away, equipped with obsolete vehicles that nobody could maintain and nobody wanted to crew. The testing at Nettuno effectively ended in May 1944 when Allied advances made the facility's location untenable. The M10 that had been under evaluation was moved north to avoid capture, eventually ending up at a German testing facility. Records of its ultimate fate are incomplete, lost in the chaos of the war's final year. The legacy of Italian evaluation of captured American armored vehicles, particularly the M10, extended beyond immediate military implications. Italian engineers who survived the war and later worked on post-war armored vehicle development brought lessons learned from studying the M10. The importance of reliability over peak performance received increased emphasis. The value of maintainability and crew-centered design became accepted principles. The post-war Italian automotive industry, which became internationally respected for producing reliable vehicles, was built partly on lessons learned during the war. Engineers like Antonio Castellano and Enzo Mariani, who had evaluated the M10, later worked on civilian vehicle development, where they applied American engineering principles they had studied. Prioritize dependability over complexity. Design for ease of manufacture and maintenance. Consider the user's experience as paramount. For students of World War II, the Italian experience with captured American equipment offers insights into the importance of industrial capacity in modern warfare. Technical knowledge alone is insufficient. Italian engineers clearly understood what made American vehicles superior. They documented these lessons comprehensively, but understanding a problem and possessing the industrial capacity to solve it are entirely different challenges. Italy lacked the industrial base, the machine tools, the steel production, the skilled labor force, and the organizational capacity to produce vehicles comparable to the M10. Even if Italian designers had created perfect blueprints, Italian factories could not have manufactured the components reliably. Even if factories had produced components, Italian maintenance systems could not have kept vehicles operational. The systemic disadvantages were insurmountable. The M10 evaluation at Nettuno represents a moment of clarity for Italian military engineering, a recognition that Italy had entered a war for which it was industrially unprepared. The Americans had not developed secret superweapons. They had simply applied mature industrial engineering to military requirements, producing equipment that worked consistently because it was designed and manufactured properly. German forces also learned from Italian evaluation reports, though Germans were conducting their own assessments of captured American equipment. The consensus across both Italian and German technical evaluations was remarkably consistent. American armored vehicles represented a fundamentally different design philosophy that emphasized operational consistency over maximum performance. This approach, while producing vehicles that might be unexceptional in individual performance metrics, resulted in armored forces that maintained combat effectiveness over sustained operations. The human stories of Italian tankers who operated captured M10s, though limited in number, revealed common themes: professional respect for the vehicle despite serving in it under desperate circumstances, recognition that Italian tanks had been tragically inadequate for modern warfare, appreciation for design that prioritized crew effectiveness rather than treating crews as expendable operators of weapons platforms. Sergente Maggiore Paolo Rinaldi, who had been among the first Italians to examine the captured M10 near Naples, survived the war and later became a mechanic in civilian life. In interviews conducted in the 1980s, Rinaldi reflected on his wartime experiences with Italian and American armored vehicles. The M10 taught me that good engineering is not about complexity or impressive specifications. Good engineering is about creating tools that work reliably when needed. Italian tanks were monuments to our industrial inadequacy, impressive in concept but failures in execution. The American tank destroyer was a monument to practical engineering, unimpressive in concept perhaps, but entirely successful in execution. I spent the war maintaining vehicles that constantly broke down. The M10 was the only armored vehicle I encountered that didn't require constant emergency repairs. That single characteristic made it more valuable than all our technically sophisticated Italian designs. The statistical summary of the M10's overall combat record provided context for Italian observations. The M10 Wolverine served extensively with American and Allied forces throughout the war. Total production reached 4,993 vehicles, manufactured between September 1942 and December 1943. The M10 equipped tank destroyer battalions in North Africa, Italy, and northwestern Europe. Combat effectiveness varied by theatre and tactical employment. When used according to American tank destroyer doctrine, emphasizing mobility and firing from prepared or advantageous positions, the M10 proved highly effective. When miserably employed in static defensive roles or frontal engagements, losses increased substantially. Overall, M10-equipped battalions achieved favorable exchange ratios against German armor, though not as dramatically favorable as the lighter, faster M18 Hellcat would later demonstrate. The M10's 3-inch gun remained effective throughout the war against most German tanks when engagements occurred at reasonable ranges and against side or rear armor. Against the frontal armor of Panthers and Tigers, the 3-inch gun struggled, requiring close ranges or flanking shots. American tank destroyer doctrine emphasized exactly such flanking tactics, so the gun's limitations were manageable within the intended tactical framework. Mechanical reliability, the characteristic that so impressed Italian evaluators, proved consistently excellent throughout the M10's service life. Units equipped with M10s maintained high operational readiness rates. Mechanical failures were relatively rare compared to both Italian and German armored vehicles. When mechanical problems occurred, repairs were typically straightforward and quick. Post-war service life for the M10 extended well beyond World War II. The vehicle continued in American service through the immediate post-war period. Foreign militaries, including those of Belgium, Free French Forces, and various other nations, operated M10s into the 1950s. Some were converted to other roles, including armored recovery vehicles and self-propelled artillery platforms. The basic chassis and automotive components proved durable enough to support decades of service. The lessons learned from Italian evaluation of the M10, combined with broader Italian experiences with American equipment, influenced post-war Italian military procurement. Italy became an enthusiastic customer for American military equipment during the Cold War, recognizing that American industrial capacity and engineering approach produced reliable, maintainable weapons systems that Italian industry could not match domestically. The philosophical lesson of the M10 story transcends armored warfare and offers insights applicable to any complex engineering challenge. In military equipment, business systems, or consumer products, operational consistency often matters more than peak performance specifications. The best design is frequently the one that functions reliably when needed, not necessarily the one with the most impressive theoretical capabilities. This principle was demonstrated repeatedly throughout World War II. German tanks were often superior to Allied tanks in armor protection and gun performance, but German tanks spent too much time broken down or awaiting repairs. Soviet tanks were crude and uncomfortable, but Soviet tanks were simple enough to be manufactured in vast numbers and kept running under harsh conditions. American tanks and tank destroyers like the M10 represented a middle path, adequate performance with excellent reliability. The Italians learned this lesson at tremendous cost. Italian tanks were neither particularly well-performing nor reliably functional. They combined the worst aspects of all approaches, inadequate for combat and unreliable in operation. The M10 evaluation documented precisely where Italian armored vehicle development had failed and what characteristics actually mattered for combat effectiveness. For modern military vehicle designers, the M10 and Italian responses to it remain instructive. The importance of maintainability is now universally recognized. The value of crew-centered design is accepted doctrine. The necessity of reliable automotive components is understood as fundamental. These principles, which Italian engineers articulated clearly in their 1943 and 1944 evaluation reports, have become standard practice. The story of Italian tankers examining captured M10s and admitting they had never seen mobility like it represents more than a narrow technical evaluation. It represents a recognition of systemic industrial inadequacy. Italian engineers were not stupid or ignorant. They understood engineering principles perfectly well. But understanding principles and possessing the industrial infrastructure to implement them are different things entirely. The M10 succeeded because it emerged from an industrial ecosystem capable of producing reliable mechanical components at scale. American factories could manufacture transmissions that functioned properly because they had the machine tools, the skilled workers, the quality control systems, and the organizational structures necessary for consistent production. Italian factories lacked many of these elements. Even when Italian factories produced components to specification, which was inconsistent, the specifications themselves were often inadequate due to material quality limitations. The evaluation at M10 documented this reality exhaustively. The reports survive in archives as primary sources, revealing what Italian professionals really thought about American equipment when examining it objectively. These reports are remarkable for their honesty and clear recognition of American advantages. There was no face-saving propaganda, no ideological denial. Italian engineers simply documented what they found and reached unavoidable conclusions. The conclusion, documented across hundreds of pages of technical reports, was inescapable. America had developed armored vehicles that Italy demonstrably could not match in operational reliability and manufacturing quality. Not because American engineers were more brilliant, but because American industry was more mature. Not because American designs were revolutionary, but because American manufacturing could execute designs consistently. Not because American tactical doctrine was necessarily superior, but because American equipment reliability allowed doctrine to be executed as intended. The captured M10, that single tank destroyer evaluated at M10, became a symbol of that realization. One vehicle among nearly 5,000 produced, revealing truths that Italian engineers had to confront professionally, even as their nation collapsed militarily and politically. The Americans had achieved in armored vehicle production what Italy could not achieve. Not through secret technology or revolutionary innovation, but through superior industrial organization, better manufacturing capability, and clear-headed prioritization of reliability over performance. The tank destroyer that consistently worked defeated the tanks that constantly broke down. The straightforward, maintainable vehicle achieved tactical success that sophisticated but fragile vehicles could not deliver. Mass-produced adequacy triumphed over limited production of temperamental equipment. In the end, the Italian evaluation of captured M10s represents one of the war's clearest moments of technical honesty. Professional engineers evaluated enemy equipment with scientific objectivity and reached unavoidable conclusions. The American approach to armored vehicle design was systematically superior for modern mechanized warfare. Not superior in any single performance parameter necessarily, but decisively superior in the factors that actually determined tactical effectiveness. Production quality, operational dependability, field maintainability, and crew-centered design. These weren't glamorous attributes that inspired national pride or generated propaganda value. They didn't create the emotional response that powerful guns and thick armor produced, but they determined combat outcomes decisively. The engineers at M10 recognized this truth. Their reports documented it explicitly, but their knowledge came far too late to influence Italian military outcomes and could not have changed them even if recognized earlier. Italy's industrial inadequacy was systemic and unfixable during wartime. The nation had entered a conflict for which it was structurally unprepared, lacking the industrial base necessary for sustained modern warfare. The M10 evaluation stands as testimony to an eternal principle that transcends its specific historical context. Industrial capacity determines military capability in modern warfare. Technical knowledge without industrial infrastructure is insufficient. Understanding problems without resources to solve them is frustrating futility. Italy understood what it needed to compete militarily, but lacked the means to achieve it. This is the enduring legacy of Italian tankers examining captured M10s and the profound lessons they derived from one American tank destroyer. The Americans built vehicles that worked consistently because they possessed the industrial capacity to manufacture reliable components. The Italians built vehicles that failed regularly because they lacked that industrial foundation. No amount of engineering skill could overcome systemic industrial limitations. The Italian engineers who evaluated the M10 were consummate professionals, documenting what they observed with scientific precision. Their reports were models of technical analysis, remarkably free from propaganda despite the ideological pressures of the era. They identified the M10's characteristics honestly: its adequate but not exceptional armor, its powerful but not revolutionary gun, its conventional but effective automotive components, all assessed fairly and accurately. But they also recognized fundamental systemic strengths, exceptional mechanical reliability that Italian vehicles never approached, intelligent design simplicity that Italian complexity never matched, excellent manufacturability that Italian factories could never achieve, outstanding maintainability that Italian support systems never provided. Their recommendations to adopt reliability-focused principles were professionally sound but entirely impractical given Italian industrial realities. By the time the M10 reached Nettuno in late 1943, Italy had already effectively exited the war as a unified combatant. The nation was fragmenting, the industrial base was collapsing. Whatever lessons were learned could not be applied. The knowledge became an academic exercise, understanding what should have been done, but recognizing it was impossible to achieve. The story resonates because it illustrates a universal truth about the relationship between knowledge and capability. Understanding what needs to be done is necessary but insufficient. You must also possess the resources, infrastructure, and organizational capacity to execute. Italian engineers understood that reliable, maintainable armored vehicles were essential for modern warfare. Italian industry could not produce such vehicles consistently. The gap between knowledge and capability was unbridgeable. Today, the M10 Wolverine exists primarily in museums and historical memory. A handful of surviving examples are preserved around the world, maintained by dedicated enthusiasts and military historians. Photographs from the Italian evaluation at Nettuno survive in archives, showing Italian and German engineers measuring the vehicle, examining its components, and documenting its characteristics. These images capture a moment when Italian technical confidence confronted American industrial reality. For enthusiasts of military history and armored warfare, the M10 has become recognized as an important vehicle representing American tank destroyer doctrine. It was not the most powerful tank destroyer, nor the fastest, nor the best protected, but it was reliable, effective, and produced in sufficient numbers to make a significant contribution to Allied victory. The vehicle accomplished its strategic mission of providing mobile anti-tank capability to support advancing infantry and armored formations. The Italian evaluation validated what American designers and military planners understood. The M10 worked consistently. In industrial warfare, that characteristic mattered more than impressive specifications. The philosophical lesson extends beyond military equipment into business, engineering, and life generally. Consistent adequacy defeats intermittent excellence. Reliable sufficiency trumps unreliable superiority. This principle, proven repeatedly throughout history, was documented with particular clarity in Italian reports on the M10. The Italian tankers who drove, maintained, and fought in captured M10s experienced this truth directly. They had spent years struggling with Italian tanks that constantly broke down, required specialized maintenance, and failed at critical moments. The M10 simply worked. That single characteristic, mechanical reliability, was more valuable than any amount of theoretical performance superiority. The engineers who tested the M10 at Nettuno produced some of the most honest technical analysis of the entire war from the Axis perspective. Their reports survive as primary sources, revealing what Italian professionals really thought about American equipment when examining it without propaganda constraints. The conclusion was unambiguous and professionally articulated. American armored vehicles represented a level of manufacturing quality and engineering maturity that Italian industry could not match. This recognition, documented in classified reports that circulated among remnants of Italian military technical services, was an intellectual surrender that preceded Italy's complete military collapse. When your enemy's ordinary production vehicles are superior to your best efforts, when their standard equipment outperforms your specialized designs, when their baseline capabilities exceed your maximum achievements, The ultimate outcome is inevitable. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.